Good afternoon, class. How is everybody this afternoon? Doing well, I hope? Yeah, good. So, exam is next week. I believe we're on the Tuesday, am I right?
Yep.
Yeah.
9 o'clock, I think.
Tuesday, April 14th at 9 a.m. in room A211. Oh, that's not showing you on that screen. There we go. There we go. So that will be when we have our exam. The Java exam does not allow a cheat sheet. You will be provided a class reference sheet as the back page, the same as on the previous two tests. Hopefully it's, are there any questions? No? You guys have written a couple of Java tests at this point, so, it's going to be similar in flavor. Although, of course, the questions will be on the stuff that we've covered since the last midterm. Which means that, it's actually a fairly narrow segment of the course, right? The exam is comprehensive, though, so you can expect some questions on the rest of it. But, in general, the stuff that you haven't been tested on yet is certainly going to make an appearance. So, my plan for today, I'd like to take a look through exception and mouse events, make sure that we've covered everything in there, make sure we haven't missed anything important. Then there are some published practice problems, practice questions for the final. I'd like to knock some of those out with you guys today, and I think that'll be a class. How's that sound? Yeah. It's also possible to do a big fat review similar to how we did in JavaScript this week. If you feel that's a better use of our time than the practice problems, then I'm happy to do that as well. I'll leave it to the will of the people. Sound good? All right. But first, let's take a look through, make sure we didn't miss anything. So, first topic here was handling exceptions. I seem to recall that I spoke at length on the difference between syntax and semantic errors, various types of errors. But just to recap, syntax errors are errors that prevent your compilation. Runtime errors occur after the program has been compiled. And logic errors are errors which, although the program compiles and executes, appears to have no errors, no error pops up. The program is still otherwise wrong. It doesn't do what it's supposed to do. That is a logic error. So I would call those semantic errors. Syntax errors include type errors, which are distinct from grammatical errors. So the system that Java uses to handle errors is called the exception handling system. When an error occurs, an object is created called an exception. Java then throws the exception. The exception falls through the program until something catches it. And if nothing catches it, it breaks the whole program. It ends the program. The types of things that cause exceptions: trying to access outside of the bounds of an array, trying to divide by 0, trying to type convert something using, when you're using a scanner and you're expecting the next thing to be an integer but it's not, that will also cause an exception. We catch exceptions using try and catch. If an exception occurs inside of the try block, execution is immediately stopped, and we immediately jump to the catch clause. Execute that instead. This means that the try block, the contents of the try block, may only partially be executed. It doesn't undo all of the changes that have occurred here. It simply jumps immediately to the catch. So if you've assigned to some variables before the error occurs, those variables will remain assigned. Does that make sense? Good. We can catch multiple different types of exceptions. Exceptions, being objects derived from classes, occur in an inheritance hierarchy. This is just a few of the common ones: input mismatch exception, arithmetic exception, file not found exception. All of these are different types of exceptions. All of these four are runtime exceptions. These two are not runtime exceptions, but all of these inherit from the common class exception. So, using our knowledge of not parametric polymorphism, subtype polymorphism, where are we here? We can see that interrupted, mismatch, and arithmetic exceptions are all different subtypes of exception. And multiple catch blocks operate very similarly to if-else blocks. Whichever of these is found to match the type of exception generated first, that's the one we go with, to the exclusion of all the rest of them. So, if you catch exception, just exception, that catches all particular types of exceptions, right? Because that's the common supertype. So, catch exception, just exception, functions as the else case, if we're still drawing an analogy to if then else. So if, else if, else blocks. Does that make sense? Good. Any questions so far? Good. So, in addition to catching exceptions, we also have the ability to create them ourselves. Using the throw keyword, we can take an exception object and launch it as an attack against the program. Launch it in such a way that the exception must be caught by a try catch. In order to do this, we need an exception object. So we use our ordinary Java syntax for producing a new object. The new keyword and the name of the class called as a constructor. It is useful to provide a string as the first argument to the constructor because this becomes your error message. Your chosen on-the-spot error message. Does that make sense? In some ways, the behavior of throw is similar to that of return. Most of the time, you won't be throwing inside of a try block that you've made yourself. Something like this. Does this seem like a new marker to you? This is supposed to be a new marker. What a way to run a railroad. Did someone put an old marker back in the box? If so, shame. Shame on that person. New markers specifically for this class. Let's see if blue is any better. See, that's what a new marker looks like. Good grief. Good grief, Charlie Brown. You'll never see this in practice. Right? There's no point. Even if you put an if statement in here. What try catches are usually used for is bracketing some kind of method call that might throw an exception. Right? Like scanning next int, for example. Something like that. So, in this sense, because a throw, even when you've written one yourself, is not likely going to occur inside of a try catch in the same method. Often the purpose is to kind of break out of the method we're currently in. They function somewhat like a return statement. They immediately terminate the method, throwing an error that then has to be caught. It's like exiting with an error state as opposed to exiting normally. Return is your normal exit, throw is your abnormal exit. Make sense? Any questions? All right. All right. So now we're on to lists, array lists. You guys need me to review array lists, or you guys handling them reasonably well? Yeah. You'd like me to go over them?
Maybe a bit, sure.
Sure, okay. So, array lists are similar in many respects to arrays. They are linear organizations of data. The difference with a list is that the data structure is dynamic. We do not declare up front the amount of memory that a list occupies. We do that with an array. Instead, the list is allowed to dynamically grow and shrink as the needs of the program require it, right? To declare an array list Array lists are, arrays which present the interface of a list. Java's doing all of the work in the background to make an array behave like it's a list. Fine, sure. To declare one, it's somewhat similar to declaring an object of any other type. However, because Java is a well-typed language, a statically typed language, we do still need to know what the type of the members of the list are. This is different from how both Python and JavaScript behave. Lists in both of these languages are allowed to have multiple different types exist within one data structure, somewhat harmoniously, in theory. However, in Java, as I said, the data structure underlying this thing is an array. Arrays must be monotyped, right? Arrays are only permitted to have one type in them, right? So, array lists in Java must also only have one type in them. So the array list needs to know what type its elements are. Using our Java knowledge up to this point, we don't really have a way of doing that, right? If we consider what we would pass to a constructor to tell it what type to declare a variable, right? This is problematic. At best, we could say, oh, well, let's throw an object of a particular class in there, test to see what kind of class it is, save that class, and then declare a variable of that type. But even that, like, you're not permitted to use variable names as types, right? You run into a problem. The solution to this in Java, and I hope everybody's paying attention because this is going to return in full force in data structures and algorithms, is the generic. Generics are type variables, right? We pass a type in using the angle braces. This types the elements of the array list, in the case of the array lists. So, the one thing though, is that that thing has to be a class and not a primitive, right? So we could very easily produce an array list of strings right? Strings are objects in Java. I almost said JavaScript. Strings are objects in JavaScript as well. But they're also objects here in Java, the language we're learning. But if I were to provide a primitive, such as int, I run into a syntax error. I'm not allowed to use primitives. So, but of course, it's a little bit silly to have a data structure and say, okay, you can put anything in here except a number, right? That's a little bit silly. So there is a way to do it. All of your primitive data types have wrapper classes. In the case of int, the wrapper class is called integer with a capital I. Aha! We now have objects. This even works seamlessly. We don't have to declare an object of type integer to, use it as a number. And the reason for that is because of a process called auto-boxing. If I have the number 5, it's kind of like a form of polymorphism, right? If I have the number 5, I can simply assign it to an integer, which is an object, and not a primitive, because Java's like, oh yeah, okay, that's the wrapper class for this one, so I'll just pack that up for you. Auto-boxing. Also, if you needed any review on what the 8 primitive types are in Java, this is the complete list. We have byte, short, int, long, float, double, char, and boolean. A byte is kind of like a super short. How many bits in a byte? Good. How many bits in a short?
16.
Correct. How many bits in an integer?
32.
How many bits in a long integer?
64.
Correct on all fronts. Very good. Very good. So, in terms of working with array lists, unfortunately we are not able to use square brace notation in Java for this. So it goes. We have to access things through methods. They're relatively, straightforward methods, however. So if we wish to add an element to the list, we use the add method. If we wish to add it at a particular index, we specify the index and then the value to be added. Remove removes at a particular index. Get accesses the value without removing it or damaging it. That's your read operation. Make sense? Unfortunately, to access the length of an array list, you do not use .length, you use .size. Java. You should be consistent about these things, Java. You should be consistent about these things. A dot size, right? Enhanced for loops will automatically pluck values from an array list, and you can just use them as whatever data type they are. So enhanced for loops work. Make sense? Any questions? Yeah.
So 2 questions. The first one is for syntax, do you need to declare the type of variable twice, like one on the left and one on the right?
I believe the second one is implied and does not need to occur.
But do you need the angle brace as well on both?
I believe you do. I believe the angle braces are syntactically required. But yeah, you'll notice that the this is not. I often just provide it because, I don't know, Java is such a verbose language. I like to make it even more verbose. But yeah, the value here is actually implied by the value provided here already. So no, you don't have to provide it twice, but I often do.
Okay.
Probably because, I mostly teach Java rather than actually develop stuff with it.
And just another question. So
Yes.
on the midterm, we had this question with arrays where we're parsing through a bigger array and then moving them, if it's an even or odd, we're
Mhm.
moving it to a smaller array. And I think the answer is you needed 2 loops, right? But
Mhm.
for an array list, let's say on the assignment, you have your array list of geometric objects. if I just want to parse all the circles and move them to like another array list, I can just do it with one loop, right?
That's right.
Like, yeah, like the size would dynamically just shrink, I guess.
Yeah,
Okay.
precisely so. So that question you're referring to on the midterm, the reason you required 2 loops, the purpose of the first loop was to calculate how big the output array needed to be, right? You need to know that to declare it, to start populating it,
Yeah.
right? A list, on the other hand, you can simply declare the list up front, if we were to use a list for the same problem, right? You can declare the list up front, add elements to it as you encounter them in the second loop, and then you only need 1 loop.
So how come like we don't just use array list over arrays in general? It just seems so much better.
Performance.
Okay.
Lists are like, they're good for some types of operations, but they're not good for other types of operations. That's one type of operation where it's useful. But, and you know, like the purpose of the the purpose of the Java array list is to try to combine the advantages of the array with the list, right? So I know about arrays and lists separately, so I'll talk to that, right? I'm not sure about the particular manner in which Java is blending the two in its like prelude, but so if you consider if we reconsider the difference between arrays and lists, right? An array is simply a linear arrangement in memory of some values. A list takes each value and essentially scatters it across memory, each in its own individual cell, right? Where each cell points to the next using a memory reference. And then the last one points to nothing. No reference, right? So, first of all, which one of these is more complicated?
One on the right.
That one's more complicated, right? So, keep it simple, stupid, right? This is the more direct implementation of what you're trying to do, so it will never go away because it's more basic, right? Just on kind of on that level already. But let's see how long it takes us to access this element. All right? I know the starting address, right? I know that these are 32 bits wide, because they're integers, presume they're integers. I know I'm accessing element 0, 1, 2, 3, 4, 5, 6. This was given to me by the operation. So I can say 6 times 32 plus 800. It takes a fixed amount of time to calculate that, right? No matter what this is, that always takes the same amount of time to calculate. Once I know the memory address of this cell, I can just read it. So, to access any particular element of the array takes a constant amount of time. It is not dependent on the size of the data structure. In our stupid little, 8-element array, it takes the same amount of time as it would in an array of 10,000 or 10 million. Doesn't matter, it's the same amount of time to access any point in the array. Make sense?
Yeah.
But this guy, I can't just jump here. That's a random location in memory. So how do I get there?
One by one, right? Purposely.
Yeah, you have to start at the beginning. And this is actually, the term for this is walking the data structure, right? But you have to walk through the data structure until you hit the node you're looking for. This does not take the same amount of time, regardless of how big the data structure is. If you're looking for the 6th element, it takes you 6 steps. If you're looking for the 6,000th element, it takes you 6,000 steps. 6 millionth, 6 million, right?
Yeah.
So, although it's very convenient to add new elements to these things, getting stuff out of them again takes time.
So ideally, like if you're making like a group of objects and you only have a small amount, you use like an array list, I assume. But if you have like 1,000 of like objects, you would use array things.
Yeah, like if your size is small enough, like you might as well do a dynamic data structure, right? Because like as the size of the data structure contracts, the performance of these two like comes in line with each other, right?
Yeah.
Although this one's always a bit faster,
Oh,
right? Like, you know, if you were to graph it, right? This is like the access time of an array. This would be the access time of a list, right? So yeah, if you're only talking about this much, that's not that big a gap, right? And if you're only accessing the first element, then it makes no difference, right? But what's more important than the size of the data structure is what you are doing with it, right? What types of operations are you performing on it and how frequently, right? So think of it in terms of ratios. Lists are easy writing, hard reading. Arrays are hard writing, easy reading, right? So it depends on the ratio. How many reads are you doing for every write? How many writes are you doing for every read, right? So, or at least when I say write, I mean like adding to the end of it, making it bigger, right? So if in my application I'm writing once for every 1,000 times I'm reading, which one should I use?
probably array, right?
Yes. But if I'm reading once for every 1,000 times I'm writing, which one should I use?
The one where array list.
Exactly. Right? So that's also like a real consideration. Word on the street. I have some friends who like I did my grad school with who are like out in industry, and they feed me information about like, yes, Rust is becoming quite popular actually, stuff like that, right? Yeah, like a friend of mine I play video games with on the weekends is like an actual proper Rust developer, right? Lists are now falling out of favor as a practical consideration because this advantage becomes absolutely enormous when you start talking about CPU branch prediction, right? So ever since CPUs have started to have multiple cores, people have wondered, well, what the hell do we do with these then, right? Because it's not obvious, right? Like, most people, like the way we're trained to think about programming, and this will be true for most of your diploma, right? The way we're trained to think about programming is as like a linear path. That's like a 1 CPU model, right? Most people program that way. JavaScript and like the event system, in theory, different events can be handled by different CPUs, right? There's some degree of parallelism there. But once you're inside of an event, you're still in a linear framework, right? So one of the things that operating systems do now to try to make use of these hardware resources, they'll go forward in your program and pre-calculate like different branches of an if statement or different iterations of a loop, right? You can think about it this way. If you take many standard for loops on an array, you could give each, in a lot of cases, you could give each iteration of that loop to a GPU core, run them all at the same time. In a lot of cases,
Yeah.
right? You can do that if it's an array, right? You can't do that if it's a list. It needs to have sequential memory, right? In order to, like, if I want to read the whole array at once, right? I need to know where each element of it is and not have to walk the data structure to find the next one, right? Otherwise, I have to pre-walk the data structure, gather up all of the references, and execute them all at once. But at that point, you might as well just run it through linearly, right? So these guys, they fail on these types of like parallel applications, right? And the more GPU and CPU cores computers get, the more this guy wins over that one, even if it's a bit more convenient for us to use this as a programmer, right? Does that make sense?
Yeah.
So I'm comfortable calling it here. Arrays win. Arrays win. Lists are still important, though. Oh man. There's an XKCD cartoon about this I have to show you now. There you go. Here's my super nerdy joke. It's my super nerdy joke for today. Did you know that you can send email from code?
I don't know.
Yeah. Yeah, this is the code you'd use to send someone an email, sending the linked list which was passed in to someone at a museum, you know. All right. So, all right, array lists. We feel we have some idea what a list is now. But, of course, you know, the question everybody needs answered: what effect does this have on UML? So, if you consider UML diagrams where the arity of an association relationship is represented by an asterisk, the asterisk means 0 or more. 0 or more. Because no upper bound is given for the number of banks associated with a customer or the number of bank accounts associated with a bank, we would want a dynamic data structure. We don't know how many, so we can't declare an array. At least this is the position of the slides, right? So in this sort of situation, this is where you would want an array, or an array list. In actual reality, this entire example is fictitious because that, my friend, is an SQL database. Nobody represents this data inside of Java. They use a proper database, possibly activated with COBOL. But, you know, think of it as an intellectual exercise. You guys know what COBOL is? Did I talk about COBOL before?
Yep.
No? Yeah? Did I? Alright. Yes?
This was invented by one of the, it was invented by the woman who made like that big machine that made that translated the code
Oh, really?
originally, yeah. I believe it was.
Which machine which translated which code?
It was like the first compiler. It was like a physical machine at the time.
Oh, very cool. Yeah, we're kind of like right at the boundary between like your compiled languages and punch cards at that point.
Yeah.
Yeah.
At the time, it was just like inputting ones and zeros into the machine.
Mhm.
So
Yeah, if you didn't have memorized like the opcode for addition, like what are you even doing? You know. Yeah. All right. So, mouse events. Hopefully everybody's been working on the assignment. Mouse events are a slight permutation on the action events, which we discussed earlier in the class. I don't know that they need that much explanation, to be honest with you. There's also a fairly close analogy to add event listener in JavaScript. Having the reference to the GUI element you are adding the event to, as the first argument, you pass one of a series of mouse events, as given up here. Mouse event, mouse event, mouse event, mouse event. Pressed, released, moved, dragged, entered, and exited. There are more than this, of course. When we write the handler function for this, the event handler, we now receive a different type of event. We handle a mouse event. The mouse event object contains much information that is useful, such as the particular and precise location of the mouse click and which button was clicked. But yeah, I think that's everything in there. So, any questions? All right. So, shall we do some test review questions then? All right, let's do it. So, this works best if you have a piece of paper or a notepad or some kind of book to write on in front of you, because you should try to simulate the environment of actually like writing an answer down like this is a test. If you do not, the next best thing is an editor that doesn't give you any syntax highlighting or help. Best example of this would be Notepad if you're using a Windows operating system. Okay? Everybody ready? Steady? All right, question 1. Write a single line of code that will throw an illegal argument exception containing the message, "Nice try." Question.
I was going to answer it.
Oh, no, write it down.
No, like I have it written down.
Ah, well, give everybody else a chance. Actually, is it possible for you guys to pull this up on your own monitors so I can use the board? Yeah? Okay. Please go to Canvas and load up the document, and that'll give me some space for the answers. All right, so, question 1. How do we start?
So write a single line of code that will throw an illegal argument exception containing the message. Throw.
Throw is correct.
New.
New is correct.
Illegal argument exception.
Illegal argument exception.
Parentheses. Quote, nice try. Quote, parentheses, semicolon.
There you go. Very good. Question 2. Write the code to call a method named test method. This method might throw an illegal argument exception. Include code to catch that exception and print the message contained to that exception's message contained in that exception to system.error. I'll give you, oh, I don't know, minute and a half, yeah. So, how do we start?
Test method. In yes.
Well, we're gonna have to wrap that in a try block. So, let's put that in there right there. If we include the try, we'll need the catch as well. What type of exception are we handling?
Illegal argument exceptions.
Illegal argument exception.
And then
I'm just abbreviating because good grief. Then we want to print the message to console.
now system.
So S out E dot get message. And there you go. Did I miss anything? Oh, to system.error. There we go. System.error dot print. There we go.
So
Yes.
question on questions like this, do we have to write what's inside of the test method, or it's just assumed that?
That's a very good question. You do not.
Okay.
Yeah. So, sorry, I'm gonna. Methods will often be referenced without the need to define the contents. This is one of those cases. So if it says call a method, it just means call a method. If it says write or define a method, you're writing or defining a method. It's always very important to read the question carefully.
Great.
Question 3. Write code to create an empty class named child that inherits all of its methods and instance variables from a class named parent. I think 30 seconds should be sufficient for that one. Tomorrow is our final code review, by the way.
Is the assignment for tomorrow as well, or is it still Sunday?
Where did I set it?
Send it to tomorrow.
Did I?
It's tomorrow, but in the assignment says due the Sunday after the code review.
I think the JavaScript assignment as well is for
I was
tomorrow.
gonna say, you also send Ellen to tomorrow.
Well, let's take a look. See, I don't like setting the due date on the Sunday, because like you guys should be using the weekend to study for exams, not writing assignments. Let's split the difference. Shall we make it Saturday? Saturday okay?
Enough time.
1 day extension, launch. I'll do that for client side as well. There we go. Good. All right. So, question 3. What do you got for me?
public class child, extends parent and then empty bracket 6. And then complete braces and nothing in there.
Yes. All right. Question 4. Given the UML diagram and the declaration of for the C variable below, put a check mark beside all assignments that are legal and an X beside those that are illegal. I'll give you how's 2 minutes? Yeah, 2 minutes. There we go. So, I don't think I'm going to put it on the board. Let's just go through it. Okay. A, yes or no?
No.
That's right. B,
Do you want an explanation for each one,
no, it's, the question just asks for a yes or a no. I'll tell you why though. It's because A is the supertype of C.
or? I was going to say it's a supertype C, meaning it inherits from C rather than C inheriting from it.
Yes. B, C,
It's the same type.
yep. D,
This is inheriting from D rather than, or inherits to D rather than C.
E,
Mm-hmm.
F,
Mm-hmm. Both B and F are inheriting from C.
G,
Mm-hmm.
H,
Mm-hmm.
not H. Take a look at the arrow.
Oh, wait, is it because it's like an extension? Like extends rather than inherits? Is that
It's
why?
an association.
It's
so
association, yep.
H has an F.
Yep. Pay attention to your arrows. Pay attention to your arrows. Yep, H is association, so it is not a subtype of F, and therefore not a subtype of C. Very good. Question 5. Consider the UML diagram and code below. When the code is run, how many calls will there be to a draw method? And which draw methods will be called in each case? I'll give you, I don't know, maybe a minute and a half.
see what the meaning difference was again.
So,
Is it possible we might go to you for science as well? The price class?
I wish I did.
Alright, let's put work.
Good. Well, you should have, no trouble tomorrow then.
Yeah.
Yeah, very good. Nice. I didn't bring my notebook.
Oh, well.
Yes.
I was gonna say, with the answer for before, so
Well,
what typically mean with like variable declaration, that would mean like, with, say like CC, it wouldn't, for H, it wouldn't technically be like CH, it'd just be something else, is that what it would be, basically, since it wouldn't be the same, identity, right?
so the reason that we can't declare a new H for variable C for question 4 is that you can only declare that variable, you can only fill it with objects of a subtype of C. H is not a subtype of C. H has an F.
So then it would be FH?
No, it couldn't do that either. The association relationship does not imply any polymorphic relationship.
Yeah, because F seems to be a subtype of C.
F is a subtype of C, yes. But H is not a subtype of F, because association does not imply that. So let's talk about 5. When the code is run, how many calls will there be to a draw method? And which draw methods will be called in each case? So, how many calls to draw are we going to get? Yes? 2. The first one, obviously. Which other one?
In the second if statement.
Second if statement. Yes. So, we have a circle C declared as a new donut. Donut is a subtype of circle. If C is an instance of a cronut, is a donut a subtype of cronut? No, it is not. It is the other way around. A cronut is a subtype of donut. A donut is not an instance of a cronut. So we skip that one. But if C is instance of donut, well, yes, it is, because it was declared as a donut.
The circle C includes donut, right?
Right. So there you go. You are correct, sir.
So a question for this question.
Yes.
It's making 2 calls, but it's calling the donuts draw method twice, right? It's not calling the circles draw method at all?
That's right.
Okay.
Yeah, I was gonna say, it would call twice because both circle and donut are part of draw.
Well, so this is the way I would like you to think about how the construction of these classes will work, okay? We'll take a moment to do the diagram, right? So the first thing we do when we construct a donut object is what? What constructor gets called first? Or which constructor gets executed first?
The one that's on the class itself?
That's right. The inner one.
Oh,
So the first, sorry, is that not what you said?
No,
Sorry.
I just said the one that's on the class itself, which
Yeah.
it is the inner one. Yeah.
So circle is the inner class. The circle gets constructed first. Circle has a draw method, right? We then layer on top the donut class. donut class has its own draw method. This masks the draw method in the circle class. So, if you're interacting with a donut, that's the one that you get. It doesn't matter whether the variable was declared with the subtype, right? To understand this perfectly, you must understand that the declared type is only for the type checker. It doesn't affect runtime, right? So we have to satisfy the declared data type in order to get the thing to compile, but once compiled, the declared type doesn't matter, really. What matters is, what is the actual type of the variable? Does that make sense?
Yeah.
Good.
So like, if you want to call the circle draw method, you would need super, right?
That's right.
Otherwise, it will always call donut regardless.
Yeah, and I don't know that you could call super from outside the context of the donut as well.
Yeah.
I don't know if you can like like from outside the class step into the super class of an associated object. Maybe you can.
Because it's like a main, I assume, that it's running.
Yeah,
Or,
I don't know. I'd have to test it. Maybe you can. Maybe you can if it's public. You certainly can in JavaScript, because JavaScript sucks. Question 6. Write the code necessary to create an array and fill it with 1,000 objects of type donut. See previous question for the donut class. I'll give you 2 minutes.
I had a big question regarding my actual submission of assignment 5 and assignment 6's folder. So when I submit assignment 6, should I submit it in the assignment 6 folder?
Yes.
Or will that overwrite the assignment 5 submission that I did submit on time?
No, it'll be fine.
Okay.
It won't overwrite it.
Okay,
Yeah,
good.
yeah. And I think I already graded assignment 5, so you should have your grade for it,
Okay,
so.
I'll check, thank you.
It's done?
Like, you know, like setting the size, that type of stuff.
Show me your code. This is my main. So you do start, right? Text field, right? These guys, I see the problem. You gotta declare these as instance variables of the class. Oh wait, no wait, you have, pardon me. So this is where you set the properties for it, right? Relocate, pref length, all those things. To get the values out of them, say right here, even though this isn't the correct context, you just use the name, name being location text, dot get text, and that'll retrieve the string that's in the text box.
How do you put it on the screen? Because I tried relocating before, it just didn't show up. Like,
I'll have to, there might be something else over top of it, like the canvas. Try relocating, I didn't see any relocate methods, so it's likely everything's tucked into 0, 0 in the top left corner. You just have to move things so you can see stuff. That's probably the problem. All right. Create an array and fill it with 1,000 donuts. Yes.
Donuts, empty square brackets. D.
Donut, empty square brackets, foo. Did they give us a name?
No, just,
No, they didn't.
Foo will do
donut.
then. Equals new donuts.
In the square brackets of thousands.
That's right. Boom! 1,000 donuts. Well, 1,000 donut holes, anyways. Donut-shaped holes in memory. Now for the loop. What kind of loop do we use?
For loop.
An enhanced for loop or a regular one?
Regular.
That's right. Question 7. Write code to declare an abstract class named abs that contains an abstract method named absm that will return a string and has no parameters. Give you like a minute and a half? Maybe that's generous. Just a minute. 1 minute. Minute to win it. Yeah. So, how do we declare an abstract class?
Public abstract class and ABS.
Have a good one. What was the name of the thing?
ABS. No.
Oh yes, that's true. Abs. And how do we declare an abstract method?
Public abstract string. Since we just have to do the same thing but get rid of the class, but it's not a class, it's a method.
Right. What's the name?
ABS.
ABSM,
ABSM,
bracket, or parentheses.
because it's not taking any parameters.
Yeah.
And what do we finish it with?
Currently.
Curly braces?
Semicolon. Abstract classes do not have bodies, so you do not open curly braces. Very good. All right. Question 8. Write the minimum amount of code necessary to implement just the owner class, as shown at the right. Assume all of the other classes have already been implemented. give you a minute and a half. That's generous. 1 minute will do.
Oh, I have a question for question 7.
Yep.
If you have an interface, do you need to write abstract on the method, or is that just implied?
I don't think you do. I think it is implied.
Yeah, just skip there. Okay.
Yeah. I believe it is, because an interface can only contain abstract methods.
Okay.
So. Okay. Start me off.
Public class operating as humans.
Public class
Owner
owner
extends human.
extends Huma.
And
Then what?
dog, D equals new dog.
Yeah.
Do you have to write the association?
Hmm?
Do you have to write down the association as well?
Yes.
Right.
Yeah. Now, it's not really implied whether or not this is private or public, right? Just to be cautious, I would throw private in there, but since it's not really specified in the question, I wouldn't deduct marks for that. Question 9 is too similar to question 7 for us to do, so let's move on. Question 10. Questions A through C all refer to the UML diagram shown at the right. Question A. What are the declared and actual types in the line of code below? Foo x equals new foo child. 0, 0. So, let's just do this by hand, or by, auditory. Let's just do it. What's the declared type?
Foo.
Correct, foo. What is the actual type?
Foo child.
That's right, foo child. Part B. Write a line of code that calls foo method 2 for all of the objects stored in the variable x above. I'll give you, yes?
Would it just be x dot foo method 2?
Yes. Pretty simple. Call this method, okay. What class does foo extend?
Foo child. Or none, wait, foo pack.
I guess. I think foo pack is intended to be a package. But packages aren't classes. So I believe nothing. Or not nothing. There is one class that all classes extend by default. Object.
Wait, is foo pack like a folder?
It's a package.
Oh.
But in Java, the way that you structure your classes is anything inside of like a folder inside of the source directory is in a package with that folder name as the package name. So in a sense, yes. We didn't really get into packages very much.
Yeah.
So. Question 11. Write Java code to print 1 to system out if the variable z holds an object of type myType, and 2 if it holds an object of type yourType. Otherwise, print nothing. I shall give you 2 minutes for that. So, if variable of type z holds an object of type my type, how do we do that?
If in brackets the instance of my type.
Yes. And of course that letter is Z in Canada. S out 1. There we go. Next. If it holds an object of type your type, of course this is very similar. Else if Z instance of your type S out 2, else do nothing, which, you know, you can do something like that, but of course you don't have to. The else case could just be dropped. Good. Question 12. Add the minimum amount of code necessary to the classes below, to the side, in order to implement the relationship in the class diagram on the right. You can assume that each class is defined in its own file. That shouldn't take you more than a minute, I'd say. No matter how you slice it.
class for that one, or is it just?
Yes, we are declaring declaring the class. What sort of arrow is that one?
Association?
Association is correct. So we do not extend anything here. Now here you have one of two ways of doing it. You can either declare two separate instance variables to hold the two objects, or if you're feeling ambitious, what is it, rider? You can declare an array of riders. An array of size 2. Does save you just a little bit of time. Question 13. Explain the difference between checked and unchecked exceptions. Give one example of each. This is kind of like one of those you know it or you don't kind of situations. Anybody, can anybody tell me the difference between a checked and an unchecked exception?
Isn't a checked exception in a try-catch block and a unchecked one isn't?
No. Those would be handled exceptions. Right? Is the exception handled or not? Anybody care to take a whack at it? Yeah.
I'll try to guess. Is check the one where it runs or it stops for runtime or before runtime? And then the other one is like it throws it after the program runs, like somewhere in there.
No. No. So, you guys remember thread.sleep, right? You remember whenever we used that way back at the beginning, we had to write throws, exception name, right? Those are, oh man, those are checked exceptions. They got me. Yeah, those are checked exceptions. So thread.sleep might throw interrupted exception. It's a checked exception because it doesn't directly inherit from runtime exception. Runtime exceptions are things like array out of bounds, div 0. So for runtime exceptions, we don't know whether or not they're going to execute or not, right? We don't know if array access will be out of bounds before we actually access it. We can't predict it, right? However, some we can. These are checked exceptions, and the method has to say it throws the checked exception. Okay? An example of a checked exception. Interrupted exception, file not found exception. Unchecked, input mismatch, illegal argument, arithmetic, these sorts of things. Right. Write a single line of code in the method below so that it prints the value of both variables named x to standard output. Okay, seems pretty straightforward. Shall we just do it? Alright. What do you got for me?
S out in brackets, because it's a string, do it in another step brackets, x plus an empty string.
Sorry, run that back.
Because we're doing it as a string,
Yeah.
they're both ints, we have to turn them into strings for them.
Ah, right. So, yeah. Like that?
In another step bracket, so, yeah, plus x. And then close that one, plus, in another step brackets, this dot x plus an empty string.
Yep, that'd work. This would also work. The thing is, you're trying to avoid adding them.
Yeah, I thought you couldn't do that with the commas. I thought that was a Python thing only.
Pretty sure it works. I'm gonna try it now. Certainly works with printf. Although you have to format things a bit differently. Let's see. 5, 7. Visualize. Ah, interesting. Does it work if it's strings? All right, there's one that does that though. Does it print? Okay, fine, it doesn't work. I'll show you one that does though. Printf is the C standard library function that all the rest of them are calling under the hood. And it does support like an infinite list of commas. So, all right. Question 15. Write a declaration for a private instance variable of type double, named my constant. Write the declaration so that you could set the value for my constant in the constructor, but after that it could not be changed. Private should be obvious. What's next?
Double.
What's next?
My constant?
Would you use final here?
Yep.
Oh, there was another one. Oh, no, the other one was static. So I was,
Hey?
I was just thinking there was another one, but it was static.
Yeah.
Or a special command.
We can review what static means if you like.
Sure, yeah.
That's useful.
Forgot.
So if you just make it private, something else has the ability to change it later. But if you make it final, final being the word for constant, don't give it a value. That lets the constructor set it, but once the constructor has set it, it can no longer change. Good. Static. Let's talk about static. So, the best way I've found of describing what static means is that static variables and methods are bound to the class, not the object. Right? So, if I have a static variable, an example could be this, right? Let's say I have a class for, I don't know, Goombas, right? I could have a static static and instance are opposites, right? You are either static or instance, not both. You can have a static variable, number, which gives you the number of Goombas that are currently created, right? This might be useful information. In a video game, sometimes you clear the level when you defeat all the enemies, right? So, in this instance, inside of the Goomba constructor, we would have a line somewhere in there that would say number plus plus, right? So every time a Goomba was created, we increase that number. With static variables, they must be initialized outside of the constructor. If you initialize them inside of the constructor, say something like that, we are resetting the value of the static variable every time a new Goomba is constructed. Therefore, you're losing the count when you do that. So, plus plus is correct in this situation, right? But this allows you to do things like, you know, somewhere else in some other piece of code, Goombas.number. And this will just let you read from anywhere else in the code the number of Goombas that exist. Does that make sense?
Yeah. So it's like a starting number that the class basically remembers, and you can always retrieve it.
Yeah. So the important point there is the class remembers it, not any particular object, right?
Yeah.
So that's a static variable. Static methods are somewhat similar, right? Main methods are static, right? That's a method. Method. There we go. So the main method is void. That means it doesn't return anything. It's also static. That means there's one attached to the class, not a separate one attached to each object. Because otherwise you would have bedlam, right? Basically, if main weren't static, you would need to create an object to create an instance of the main method before you ran the program. This is a nonsense. You can't create objects until the program is running, right? You're in a chicken and egg scenario. Static methods cannot access instance values, right? So let's imagine that one of the instance values here was position. I don't even care what the type is. Represents the position in the game, right, of a particular Goomba. The method attached to all Goombas doesn't know the position of any particular Goomba. So it can't access that information, right? But an instance method can access static information, because anything can access static information, even things outside the class entirely, right? If you can call Goombas.number from any context, you can do that from within the same class too. Does that make sense?
Yeah.
So that's static.
Okay.
Good review. All right. Question 16. Suppose you have a variable named passengers, which stores an array of objects of type passenger. See the class diagram to the right. Write a single line of code that will print out the output of getName for the first object in the array. Really? That seems way too easy. All right, skip. Using the same passenger variable from the last question, write an enhanced for loop to set the name of every passenger to Sally. This is also very easy. Yeah. Ooh, that's okay. Write a single line of code that will print the ASCII/Unicode value for the third character of the string variable named S. Seems like a little bit abstruse, actually. Does regular indexing work on strings in Java? It might.
Java does not support square bracket notation.
I think it's char at.
Yeah.
Yeah. Yep, char at 3 gives you the character. Then the question is, how do you access the Unicode value? Any guesses?
I know it's a method,
There's an easier way. You cast it as an integer.
So would it be int s?
I'll show you.
but in brackets int, and then after that s dot char at 3.
Yeah. So So we have this string s. I'm not sure I don't think that's part of the solution. This is the solution. S.char at 3. I think it was the third. If it was the third, then it was 2. Then Cast as int. That'll do it. If you're really persnickety, you can put more braces there. Looking good?
Sign R or 2?
That's a 2. I apologize for my penmanship.
Are we gonna be provided with like methods for the final exam, like instance of and char app? Maybe like in a diagram or something.
So you'll get the reference sheet with all of the all the methods, common methods, the same thing you had on the last one. So
Okay.
I'm not sure that instance of is there. That might be one we expect you to know. So, all right. Good job, team. All right. See you tomorrow. Code review.
Can I ask you a question about the JavaScript assignment?
Sure.
So, first question.
There we go. For the benefit of posterity, we are now recording the session. So, there we go. So, definitely did 18. I think we left off on 19, didn't we?
Yeah.
Yeah. Okay. I have a method named bad method. It takes no arguments and has no return value, but when it's called, it might throw a special kind of exception called a bad method exception. Write code that will call bad method and print error to standard output if it throws the bad method exception. Oh, I think you should be able to manage that in 2 minutes, don't you think? Just as a reminder, the best way to engage with these practice questions is to write your answers on a piece of paper. Failing that, the best way to do this is to have something like Notepad open that you're typing into, because that doesn't give you any syntax assistance. For on the test, you shall receive none. I prefer chalkboards, to be honest. Maybe at break I should go get like some tape and hang that poster.
Yeah.
Yeah, why not?
Hanging where?
Yeah, just like back there or something.
Are you allowed to do that?
Allowed to. No.
Oh, can you? Absolutely.
Yeah. Who's gonna know? Who's gonna know? Alright, now what you do is you hang it on like the back of that pillar or something. Somewhere like maintenance will never see it, you know?
Oh, the back of the screen.
Yeah, perfect. Yeah.
Yeah.
Alright. So, how do we start this one off? If we want to catch an exception, what sort of construct do we use?
Try and catch.
A try-catch, yes, very good. Try, what are we putting inside the try? Bad, whoa, bad method. What are we catching?
Bad method exception.
Bad method exception. And what are we doing in the case of it occurring?
Printing error.
There you go. Not bad. Something you may not have known about me, but whenever I print an error message to console, I always include at least one exclamation point. Your program should be enthusiastic. I also always write my little scripts and things to be like just a little bit obsequious. It's like, oh yes, thank you, yes. Excuse me, sir, but you didn't enter that quite right. Would you mind providing a correct value? You know, because like if you're gonna write like software robot servants, they should at least be polite, right?
It does.
Question 20. What do you have to add to the constructor? What do you have to add to the constructor shown here to force a call to the no-arg constructor of its parent class? I mean, we could just answer this one. How do you call the no-arg constructor of the superclass? From within this piece of code, and where do you put it? Anybody?
Super.
Super is right. Where do you put it?
Above the this.x.
Above this .x. Yes, correct. Now here's another question. Do you have to?
No?
That's correct. Why?
Well, would it be because the positioning wouldn't really be too much of a factor? Because like you could possibly put it say below this .t as well.
No, when you're calling the super constructor, or if you're using super or this inside of a constructor, that always must occur on the first line of the constructor. In actual point of fact, super with no arguments is already called by default without having to explicitly specify. But if you want to do it explicitly, that's where you put it. Question 21. And then we're through the short answer and we're on to some gosh darned coding questions. Good morning. give examples of two different ways to use the super keyword. Explain what each use of the super keyword does. Well, we kind of just did one of them, didn't we? But that's, alright, so what's the other way that we can use super?
Super with a period instead of brackets.
Sure, and what does that do?
It calls the parent's variable, or like, a thing,
Variable or?
a method.
That's right.
Yeah.
So, using the super keyword, basically in place of the this keyword, allows us to access the super class's variables, well, public variables and methods. So yes,
So you could use it in place of this.
yeah, essentially both places that you will often see this used, you can also see super used to reference the parent class. Many other languages have something similar to this, but they call it parent rather than super. But, you know, Java is just such a super language.
Wait, but using it to call other methods or reference parents classes, would those be considered different uses, or?
Using super to call a constructor in a super class, that's one use. Using it to reference variables and methods of a superclass, that's a different sort of use.
Alright.
Application question. Consider the UML diagram below. Your job is to write the minimum amount of code to implement everything in this diagram exactly as shown and according to the principles of good object-oriented design. Here are some implementation notes. Carnivores eat animals and herbivores eat plants. Yes. Note that some class names and methods are italics. Yes. What does italics mean in a UML diagram?
Abstract.
Correct. A carnivore contains a set of prey animals, animals that it eats. A prey animal can be added to the list using the add prey animal method. You can check if a given animal is prey for a given carnivore by calling isPreyAnimal. A wolf has a numeric social rank that can be increased or decreased by 1. Treat the pound and tilde symbols as if they were negative private. It's a little weird, but okay. So, how's about you folks take 4 minutes, implement the animal class. Sound good? We'll break this one down. Not 4 seconds. 4 minutes. So how many exams you guys got?
3.
3? This one, Java, and what's the other one?
Math.
Math.
Discrete math and stats.
Math stats, yeah. Systems analysis doesn't have an exam?
No, we just have like a big report for today.
So, let's take a look at this. So what's the very first thing we notice about the animal class?
Abstract.
It's abstract. Very good. Public abstract class animal. We've got an instance variable, species Latin name. Species Latin name. Just going to do a few abbreviations to save time. We need a constructor, we need a getter for Latin name, and we need, what's special about that eats method?
It's also abstract.
It's also abstract. Very good. So, public animal, is the constructor taking anything? A string. Very good. String. We then have a getter of the normal sort and variety. And then we have the abstract method eats. There we go. Not too bad. Was 4 minutes too long, or was that about the right amount of time? Alright. Herbivores are a bit simpler. So let's do herbivores first. Let's take a look at the herbivore class. Let's get that implemented. I think 3 minutes is probably sufficient. First, do we notice anything about this class?
It's abstract.
It is abstract, very good. Herbivore. We have a instance variable, private instance variable. It's an integer. It's num stomachs. We then have a constructor. Public herbivore receives a string which will be its Latin name and an integer being its stomachs. We need to pass the Latin name to the superclass. How do we do that? This is one point that people have been sort of getting reasonably wrong on test 2.
Is it super bracket and then species Latin name?
That's right. Super Latin name passes it to the super constructor. Then num stomachs is equal to stomachs. Ta-ra. We need to now write the implementation for the eats method. This is overriding the abstract eats method in the animal class. However, the override tag is optional. It does not need to be part of a completely correct solution. Recall that the purpose of the override tag is to inform the compiler that you think you're overriding a method, and then the compiler will check that for you. So it's good to include, but not necessary. Public string eats return vegetables. And that's just about it. Ah, wait, I forgot one thing. Extends animal.
I was gonna mention that.
Yeah, I caught it. All right, cow is quite simple. So let's see if we can knock that out in a minute and a half.
thought someone was just missing a button on the windows for a second, but no, that was just the music.
That was me, yeah. Don't you autoplay, you stupid thing. Alright. Cow. What do you notice about the class? What do you, yes?
No variables.
Well, yes. I'm thinking about, like, the name of the class specifically. What do you notice?
It's not abstract.
It's not abstract. Both of the previous ones have been abstract, this one is not abstract. And you're right, it also has no variables. Gesundheit. What is its relationship with the herbivore class?
It extends it.
Yes. It has but a single constructor,
Public cow.
public cow. String, Latin name.
Integer number of stomachs.
Stomachs. Although, really, I might quibble. As the number of stomachs that a cow has is defined by its species unless it's had surgery. So, 4. It should just be 4, it should be passed in, but whatever. So, given that we have no variables at this level and we're passing all of this information, what do we do?
I was gonna say, shouldn't you replace that curly brace there with a semicolon?
No, the constructor is not abstract, and I don't think there is such a thing as an abstract constructor. Super. Latin name, stomachs. Apparently this is a cow with a configurable number of stomachs. Ruminants have 4 stomachs. And in case anybody was interested, which perhaps you weren't, the Latin name for the cow is Bos taurus, which of course translates in English to boss cow. It's a joke, you can laugh. Alright, let's do the carnivore class. This one's got a bit more going on. So, let's give you 6 minutes for this one, eh? 6 minutes?
Question for this one.
Yeah?
Are we meant to use an array or array list?
Well, take a look at the UML diagram. What's the error key given as?
I mean, it can have any number, right? So that is-
Right. So is that an array or is that an array list? If the music is just annoying, I can stop.
No, no, keep it on.
Yeah? Okay. Alright. Carnivore. What do we immediately notice about this class? Abstract, very good. Public abstract class
Carnivore.
carnivore. What is its relationship with the animal class?
Extends it?
It extends it, yes, very good. Let's take a look at our instance variables. We have number of teeth, which is an integer.
That's private?
It is private, yes. I would certainly say that most animals have teeth, so the number of teeth might be something you would have in the animal class rather than the carnivore class, but so it goes. We have a constructor. Oh wait, whoa. Before we do the constructor, Is that all of the instance variables? He wouldn't be asking the question if the answer was yes. What else do we have here?
Arrays.
Hmm?
Arrays.
Yes, we have array, which is an array list. An array list of what type of thing?
Animal.
Animal. That's right.
No, Boolean.
Animal. Array equals new array list. Boom! Now we can do it.
Oh, just a question. Could you have use herbivore as a type there, or I know there's a checker that checks it later, but I was just wondering if you could.
Well, if we're going according to the UML diagram, the prey association is associated with the animal class rather than the herbivore class. I might also note, carnivores can eat other carnivores.
Oh, that is true.
Yeah. So, yeah. Yeah, there's absolutely no solidarity between carnivores. Public. Oh man, this marker's dying. Public. Carnivore takes string and int, string Latin name int, teeth. Latin names, of course, contained in the superclass. Super passing Latin name. This dot num teeth is equal to teeth. Bada boom. Add prey animal. A prey animal can be added to the list using the add prey animal method. Public void, that's void I think, right? Oh, I forgot set teeth, but honestly, like, I don't know if it's even useful to show it. Yeah. Public void,
I mean, good.
yeah, I'll probably do it. Add prey animal, let's call this victim.
Oh,
Prey dot add victim. Set num teeth. Public void set num teeth int teeth. This dot num teeth is equal to teeth. Boom. What else we got? Is prey animal. Takes an animal and checks to see if it's in the animal list. Public Boolean is prey animal
Animal.
X, I don't know, whatever. So, there's an interesting thing. We need to check to see if this animal is a type of prey animal. So this gets a little bit tricky, right? We have to understand well what is going on here, right? Is our array list of animals filled with objects or classes?
Object.
It's filled with objects, right? Not classes. So, if we're using a sort of physical real world analogy here, which is always dangerous when you're programming, right? If we're using a physical real world analogy, we might be inclined to think, oh, what we're doing is saying, okay, a wolf will eat deer and rabbits, but it won't eat like elephants, right? But this is not actually how the code is laid out. How the code is laid out, this wolf will eat only the specified cows, right? That cow, that cow, that cow, but not that cow over there, right? So, what we are doing is we are checking to see if the reference passed is the same as any of the references in the list. That's what we are doing, okay? So, we can do this with the quote-unquote enhanced for loop. For animal y in prey, if x is equal to y, notice I've used double equals here, because that one actually checks to see that the references are the same. Return true, otherwise return false. If you are not yet familiar with this sort of construction of loop, I'm sorry this is very far away from you guys over there. I should start using this board too. If I could pull this off the wall and kind of angle it towards you, I would. This type of loop construction is very powerful, actually. If you're doing a search, right, as soon as the condition for the search is met, you return from the method with the result. This means you don't have to check the rest of the loop, you don't have to check the rest of the data structure. If you put a return case for the negative immediately after the loop, the implicit logic there is, in order to reach that end statement, I had to go through every single iteration of this loop, and not once was that if statement activated. Right? So, we return the opposite case. Okay, good. Now we just have to do eats. Public string eats. Return flesh. Because that's what carnivores eat. So, I think that's everything for our carnivore class. Let's now do the wolf class. And that's not as interesting, so let's give you 3.5 minutes for it, I think. There we go. This is all this is all music from the first Mario Party game.
Oh, that was from Mario Party. I thought that was Pikmin.
Nah. Mario Party has good music for this application because it's got a lot of tracks that are like 1 minute long for all the mini games, you know. Oh, no, stop, shush, stop it. There we go. All right. Final destination. Public class Wolf. What is its relationship with the carnivore class? Extension. We have an instance variable, social rank. Or that's private, pardon me. Constructor taking three things. Public Wolf, string Latin name, int teeth, int rank. Honestly, of all of the ones we've done so far, really only this one kind of properly understands what a variable is, right? Because if you think about it, right, the number of teeth that a wolf has is constant if you're not modeling a wolf being able to lose them, right? The Latin name for a wolf does not change definitionally. Like that should even be static, right? This is like the only one that's like properly actually variable, you know? But so it goes. Super! Latin name. Teeth! This dot rank is equal to rank. And then we've got an increment and decrement operation. Public void rank up rank plus plus public void rank down rank minus minus. There we go. Good? Questions? All right. Moving on. Gesundheit. I want to skip over 23 to 24 because we just did a lot of like implementing stuff. So let's do one of the like figure stuff out kind of ones. Consider the main method below. Depending on how the user behaves, there are three exceptions that might be thrown when this code is run. your job is to figure out which of these 3 exceptions might be thrown. See the list of possible ones to the side. Then rewrite the code with additions so that if an exception happens, the program prints a user-friendly message and then starts the program again from the beginning. If the user makes it through with no exceptions, the program should end. To get full marks, your rewritten code must include all the lines from the original code and should execute them in the original order, as long as there are no exceptions thrown. So, I'll give you 1 minute, look at that, tell me what exceptions. Incidentally, the Latin name for a wolf, in case anybody is interested, is Canis lupus, which means a dog that has lupus. That's another joke. So, who wants to tell me what exceptions might occur? Anybody? Yes.
If the user enters a string on either in A or B, then you will get input mismatch.
That's right. Very good. Input mismatch is one.
And then if they enter an integer, but it's outside of the range of the array, then they will get array index out of bounds.
Very good. And there's one more.
That's all I know. I
Anybody?
don't know what the last one is. Oh,
You got it?
yeah, if, wait one second. I think if they enter for int D, if
Yeah.
they enter, like, the index that retrieves the 0 from the array,
Mm-hmm.
and they will get the arithmetic.
Very good. Yes, that's correct. So, so let's rewrite the code. The scanner line and the main line are the same. The line declaring the integer array x is also the same. Now you have a couple of options here. The shorter way to do this is to group all of these potentially bad statements into one big try-catch. The other thing, which honestly demonstrates perhaps a little bit more understanding of what's going on, is to wrap every individual line that might fail inside of its own try-catch. Or at least group them according to the exceptions that might occur. So let's do that one. Try. There we go. SC next line. E. Input, mismatch, exception, S out, not an int. Next, we have the out of bounds exceptions. Try int c is equal to, what is it, x at a, int d is equal to x at b.
Would you do like two catches for this one?
See, I'm thinking about it, right? And I think no. Now that I'm thinking about it somewhat more in depth. Here's the thing, right? Let's say an exception occurs here. That means the next line is not executed. What does the next line do?
It skips it, no?
It skips it, but what was it doing? What is it not doing if an exception occurs?
Oh, so you don't initialize the D.
B, yeah. So this bit here, where we are creating the B variable, doesn't happen. Which means it won't exist down here if we try it. So, I think what we would like, if we want to maintain this structure, there's a simple fix. Declare them up front. It's also like, now that I'm thinking about it, we might also run into block level scoping problems if we are declaring variables inside of try blocks. I'm just going to try it for a moment.
On the assignment, I think I had to move out all my declarations from inside of the try block too. So it's possible.
Mm-hmm. Yep, we run into scoping issues. So we have to declare our variables outside of the try block. Trickier than it seems, eh? So, having gotten this far, catch array out of bounds exception. The dreaded and deadly AUB. S out bad index. And finally, we want int e or not int, e is equal to c divided by d, catch arithmetic exception, s out div 0 error. And then don't forget the last thing you do is you print e. And there you have it. Make sense? Any questions? Okay. Well, the time is currently 10:16. I feel at this point it is appropriate for us to take our usual 15-minute break. When we resume class, it's going to be code review for assignment 6. So, all right, please be ready and prepared to resume class at approximately 10:31. Thank you and good evening.